Hallo und herzlich willkommen zu unserem Matchday KI und Machine Learning hier aus unserem Studio in der ECE in Poppenbüttel. Ich begrüße euch ganz herzlich vor den Bildschirmen in den Klassenzimmern, liebe Schülerinnen und Schüler. Schön, dass ihr so zahlreich heute dabei seid und natürlich auch ein herzliches Hallo an alle Gäste und Lehrkräfte. Genau, gemeinsam mit unseren Vortragenden wollen wir heute den Begriffen KI, also künstliche Intelligenz und Machine Learning, zu Deutsch maschinelles Lernen, ein bisschen auf den Grund gehen. Mein Name ist Steffi, ich bin Projektkoordinatorin bei der NAT und ich werde euch heute durch den Tag begleiten. Das tue ich aber nicht alleine, sondern ich möchte euch gerne gleich Sonja, unsere Werkstudentin, vorstellen, die nachher eure Fragen, die ihr mit dem Tool Slido stellen könnt, an die Vortragenden weitergeben wird. Genau, das Tool wollen wir jetzt auch eben kurz einmal ausprobieren. Ja, wir haben ein kleines Warm-up für euch vorbereitet. Ihr dürft jetzt gerne einmal eure Smartphones rausholen. Also etwas, was im Unterricht sonst eigentlich nicht so erlaubt ist. Genau, in den Browser gebt ihr, um das Tool zu benutzen, sli.do ein. Ihr seht es hier auch neben mir. Oder slido.com und dann sucht ihr nach der Session des heutigen Tages. Das ist Hashtag MD für Matchdays 2201, das heutige Datum. Oder ihr benutzt einfach den QR-Code. Alles werden wir hinterher auch immer mal wieder einblenden. Genau, meine Kolleginnen werden dann im Hintergrund die Fragen ein bisschen vorsortieren und auf Überschneidung achten und diese dann freischalten. Ihr könnt Fragen dann auch liken, also wenn ihr eine Antwort auch gerne hören möchtet oder euch eine Frage besonders interessiert, nutzt diese Funktion sehr gerne und schaut einmal vorher, ob eure Frage vielleicht schon in ähnlicher Form gestellt wurde. Genau, wir würden euch bitten, natürlich fleißig eure Fragen zu stellen und sachlich beim Inhalt des heutigen Tages zu bleiben. Liebe Sonja, bist du denn schon da? Ich sehe dich schon.
Ja.
Hi.
Hallo.
Genau, dann starten wir mit dem kleinen Warm-up.
Genau. Ich fange mal direkt mit der allerersten Frage an. Und zwar würde es mich interessieren, wie häufig ihr denn ChatGPT nutzt. Sehr gut, die ersten sind schon drin. Das freut mich.
Wie zu erwarten, viel Nutzung von ChatGPT.
Ja.
Und zumindest
Ist auf jeden Fall schon mal sehr positiv zu wissen, dass niemand nicht weiß, was ChatGPT ist.
Genau, alle können damit was anfangen mit dem Begriff.
Okay, aber es gibt auch welche, die es gar nicht benutzen.
Oder nicht wissen, dass sie es benutzen. Genau, da tut sich jetzt nicht mehr so viel.
Ich glaube, es ist gar nicht so einfach, mal eben kurz ins Slido reinzugehen, anscheinend, so früh am Morgen. Aber vielleicht holen wir sonst auch bei der nächsten Frage noch mehr Leute ab. Und zwar, welche Ausrede könnte eine KI nutzen, um deine Hausaufgaben nicht machen zu müssen? Die erste Antwort wäre, mein Server ist abgestürzt. Die zweite, dein Hund hat mein Kabel durchgebissen. Ich bin noch im Update oder sorry, ich halluziniere. Was gefällt euch denn am besten?
Eindeutig der Server.
Das ist wahrscheinlich das naheliegendste. Okay, jetzt haben es aber auf jeden Fall schon mehr geschafft, ihr Handy rauszuholen.
Das ist gut.
Okay, dann würde ich sagen, gehen wir auch schon zur allerletzten Frage über. Und zwar ganz einfach, wie geht es dir denn heute? Seid ihr gespannt, was auf euch zukommt? Ihr seid müde, bräuchtet einen Kaffee oder geht so?
Da müsste doch jeder und jede was zu sagen können.
Okay, also die meisten von euch sind müde. Das kann ich verstehen. Ich hoffe, der eine oder andere hat vielleicht seinen Kaffee dabei, damit die Zeit jetzt auch überbrückt werden kann.
Ansonsten kriegen wir euch schon wach. Da bin ich.
Genau, wir haben ja interessante Themen vorbereitet. Aber jetzt nochmal dazu gestoßen, das freut mich sehr. Und alle anderen kommen vielleicht auch gleich noch dazu, um dann ihre Fragen bei Slido zu stellen. Ja gut, dann
sind wir auch gespannt.
Würde ich die Umfrage erstmal wieder beenden. Genau.
Genau, Sonja, dich sehen wir dann später nochmal wieder. Und ja, denkt daran, gerne eure Fragen auch schon während der Session zu stellen und Sonja wird die dann nachher an die Vortragenden weitergeben. Künstliche Intelligenz, kurz KI oder im Englischen AI für Artificial Intelligence. Ein Begriff, der aus unserem Alltag nicht mehr wegzudenken ist. Viele von uns nutzen KI täglich, das haben wir ja gerade gesehen, teilweise vielleicht auch ohne es zu wissen. Denn egal ob Smartphone, Streaming-Anbieter oder Smart Home Anwendung, KI steckt in vielen Geräten oder auch digitalen Tools. Und spätestens seit ChatGPT hat das auf jeden Fall auch Einzug in den Schulalltag genommen. Doch wisst ihr genau, was KI eigentlich ist? So eine Definition oder eine Abgrenzung erscheint schwer, denn wo enden klassische Simulationen oder Algorithmen und wann fangen intelligente Prozesse eigentlich an? Und was können oder künstliche Intelligenzen denn heute eigentlich schon so leisten? Auf diese Fragen wollen wir heute gemeinsam mit unseren 3 Vortragenden ein paar Antworten finden. Und uns verschiedene Anwendungspotenziale und Herausforderungen anschauen, die gerade so in der Forschung aktuell sind. Ihr habt es vielleicht schon gesehen. For the first session, I will switch in English. Because now we want to take a look behind the scenes together with Pierre-Alexandre Murena and find some answers on the question what artificial intelligence is. He is junior professor at the Technical University of Hamburg and will show us some insights in the field of human-centric AI. Welcome, Professor Murena. I'm glad you're here and take some time for us and cast some light on the terms and concepts of AI. I will hand over directly to you. You can share your presentation now.
Hello, yes, let me share. Okay, now you should be able to see my slides. Yes, I can see on the screen that you see them. Okay, perfect. So thank you very much for the invitation. Now you can see everything. Yes. So thank you very much for the invitation, and it's my pleasure to give this talk to you, where I will talk of artificial intelligence, obviously, but I will also talk about pigeons and humans, and you will see why. And in this talk, I will try to explain to you what is artificial intelligence and mostly, to be fair, what it is not. So let's start by just going back to what AI, how AI was seen back then. So when I started working with that and studying it, when I said I was working with AI, people were all asking me, okay, what do you think like killer robots will take over mankind, etc.? The answer, spoiler, is no, they won't. We are very far from that. But that was how it was perceived. Nowadays, the image of AI has changed completely. You as students probably know, probably use AI in your everyday life. This has been said as introduction. So you use it for your studies, but also at very high levels. For instance, in research, AI is used, for instance, to discover some properties of proteins or to discover something that human intelligence alone cannot find, or at least cannot find in a short amount of time. So now, definitely, our relationship to AI has changed completely. And the main difference is actually that nowadays, anyone can consciously and actively use AI tools. What I mean by that is that back in the days, I mean, AI has been part of our lives, but in hidden manner. Like, for instance, when you were browsing the internet, you had some recommended ads or some recommended music, etc. That was part of AI. I mean, lots of things you were doing in the past days were relying on some AI, but you were just passively using it. You were just seeing the AI does its stuff for you, and you didn't have to interact with it. Nowadays, you know that you are using AI tools. For when you ask something to ChatGPT, you know that you are using an AI tool and you are active in this use. And this change raises actually very important questions, which I will try to address during the presentation. The first question is, are we really aware of what AI can and cannot? I mean, I am somehow, in the sense that it's my job to be, but you as students or anyone in the street, are people really aware of what it is? The second question is, can we really trust AI systems? And that will be something I will insist on a lot today. And finally, are AI systems really able to work well with us? Because we are using them for our task, but are they really designed for that? So let me start with this very simple question. What is artificial intelligence? So yes, I will say AI, probably I mean, it's something you're definitely familiar with, AI, artificial intelligence. So the first and a bit outdated definition of artificial intelligence that designates the ability of machines to mimic human intelligence. So like to imitate us in some task, in particular, imitates our abilities to learn, to reason, and to solve problems. So I say it's a bit outdated because actually nowadays, if we think of it more carefully, it's not really much about mimicking us. What do I mean by that? Like in the positive, like it's not mimicking us in the positive sense. For instance, you might have heard of AlphaGo, so some AI system which plays Go and which won Go games against world champions, human world champions. And actually, it was realized when doing these games that AlphaGo had imagined some strategies that nobody in the history had never thought of. So it's not exactly like doing, it's doing something which humans wouldn't have thought of. So it's not about mimicking human, but it's going beyond what human can do. Okay, frightening, not so much, because it's also in the negative sense that it's not mimicking us. So there is this thing called adversarial AI. So basically, you are trying to find some perturbations, very little perturbations, that will completely destroy the abilities of an AI without being seen by a human. And here you can see on the left-hand side, these are images classified by AI. So here it says that it's a bee eater, which is correct. Here it's a parachute, which is correct as well. No idea how to pronounce it. However, sorry. And here it's a bell pepper. Yes, correct. But if you add a little bit of weird pixel in that, it makes these right-hand side pictures, which are for us exactly the same, but for the AI, it completely changed the perception. And now the bee eater is seen as a snake, the parachute as a pillow, and the bell pepper as a strainer. So we can see that it's absolutely not human in the way it predicts the labels of an image. Oh, a more reasonable definition of AI would be the ability of machines to make rational decisions to achieve their goal within their perceived environment. So here it works. It just means that the AI is inside an environment, has some perception of it. So for instance, here observes the images and is able to make a decision which makes sense. Okay. Now, how about machine learning? Because that's another term you might have heard, and for you, it's probably part of this AI constellation. Machine learning consists in making machines learn, so that's why it's called machine learning, in making machines learn their own algorithm rather than letting humans design these algorithms explicitly. Okay, let's make a pause for 1 second. What do I mean by algorithm? An algorithm, it's not something weird and mysterious. An algorithm is just basically a sequence of instructions that you follow to reach a goal. Like for instance, if you want to sort numbers from the smallest one to the largest one algorithm would be to read all the numbers, take the smallest one, put it on the very left, then take the remaining numbers, take the smallest one, put it just after the first one, etc., until you have sorted all the numbers. That is an algorithm, and algorithms have been invented before even computers were invented. That's crazy, but in the 18th century, 19th century, people were already thinking of algorithms. And obviously, computers were not there at that time. But then machine learning is about not letting us humans write the algorithms, but letting the machine define their own algorithm. So let me give you an example. This is a labyrinth, so you know the principle. You start from the left-hand side and you must find the exit. So let's say that now you're here. With a non-AI approach, the way to solve it would be to specify explicitly what the agent should do. So here, go right, right, down, down, right, and you exit the labyrinth. Okay, so here you specify all the steps in the algorithm one by one. In an AI approach, you would specify an algorithm which is more general, which is actually not working just exclusively for this problem. Like, for instance, an algorithm would be, okay, you explore randomly a direction. For instance, you go right, then up, then right, until you reach a dead end. Here, I'm in a dead end. So since I'm in a dead end, I just, what we say, backtrack. So I go back to the previous intersection. The previous intersection was here. So now I test another action. So now from here, I know that going up doesn't work. So let's go right, for instance. Okay, if I go right, oh, I find the exit. Okay, I found this. So this is an AI approach to solving labyrinths. Now the machine learning approach would be to explore millions, if not billions of labyrinths, just like, you know, walk randomly in these labyrinths. And in the end, try to learn to predict in any configuration, I'm here, I know that about the labyrinth in which I am, then what is the potentiality of each direction? So which direction should I explore next? So here you learn completely. It's not the humans telling you how you must explore. It's just you learning how you must explore. Okay, so machine learning relies on some data. So here in the labyrinth example, the data is the exploration of millions of labyrinths. Okay, it relies on some data. So can we say that machine learning is data science? Yes, machine learning is part of data science, but it's not. But data science is not only machine learning. Data science actually refers to a set of techniques and technologies related to the collection, storage, preparation, and analysis of data. Machine learning is just part of the analysis part. But before that, you must collect the data, so you must find it somewhere. You must store the data, which has lots of issues. You must prepare the data for the analysis, because usually when you collect data, the data is absolutely not in a way that you can actually exploit. So data science is much more than just machine learning. It's very different things. So as a summary, artificial intelligence contains machine learning. So machine learning is a specific kind of artificial intelligence. Inside machine learning, there is specific techniques which are called deep learning. You might have heard the words. It's just some very specific machine learning. And data science is something which contains machine learning, but not only. All machine learning is not data science. All data science is not machine learning, etc. Okay, now that this is said, let's move on to this interesting question: can we trust AIs for our tasks? And for this, I would say that we live in a civilization that believes in science, and we can answer that yes, probably we can, because there is a scientific validation. Most AI results have been established scientifically with high confidence. It means that scientists have run experiments, etc., and are able to say AI works. This algorithm works. We can use it. With high confidence. Knowing that an AI system has human performances, for instance, in interpreting X-rays, okay, and that is something that has been scientifically proven. Who among you would let this AI interpret their X-rays to diagnose a cancer? And I asked the question to a crowd one day when I was giving a presentation, and most people say, "Yeah, I do trust the AI. I mean, it's scientifically validated, so why wouldn't I trust it?" Okay, so now let me tell you a story. This story is a story of an American study made on pigeons. So American scientists trained pigeons to read some medical imaging to identify breast cancer. And the result is stunning. Actually, pigeons are super good at reading this kind of medical images and identifying tumors in these images. Okay, so what it means that a pigeon, and even better if you just like unite like the strength of like the force of like 3 pigeons, I think it was 3 or 4 pigeons, they reach performances that are the same as a human specialist, as a human expert. Okay, so now this is proven scientifically. Okay, and still I can ask you the same question. Knowing this fact, would you let a pigeon interpret your X-ray to diagnose a cancer? And here, when asking the question, usually people are a bit more reluctant to rely on a pigeon's decision to interpret their X-rays. So why? In both cases, science has proven the point that it is reliable, but still you do not really trust pigeons as much as you trust an AI. So what is the difference? Actually, the difference is, on many levels. The first difference is that AI can speak our language, especially nowadays with large language models. So, ChatGPT, for instance, they can speak exactly like us. They can speak in English, in German, in French, whatever, and give us like some results that we can understand. Yes, okay, I detect a tumor in this X-ray. Okay, and that's a difference from a pigeon that will just touch a screen. Okay, that's the first big difference. A second difference is that it seems that AI are able to justify their choices. Whatever you ask the pigeon will just like touch the screen, but not tell you why the pigeon thinks there is a tumor or not. AIs, they will give us what we call confidence score. So tell you, yeah, I'm sure like 98% that there is a tumor, etc. And some systems are even able to give you more justification. I think there is a tumor because look, in this part of the image, you can see this or that. Okay, so that's 2 big differences. A third big difference is that in the name artificial intelligence, we declared that AI is intelligent. And that's a strong mistake. We shouldn't call that artificial intelligence. We should call that, I don't know, I have no like alternative, but by saying artificial intelligence, you instantly assume that artificial intelligence is intelligent, which is a mistake. Okay, so the point, I'm saying artificial intelligence is not that intelligent. So let me tell you why I claim that. And for this, I will answer this question. How do modern AIs work? That will be the most technical part of this talk, but don't worry, it's super simple. Imagine I have some blue points and red points on this line, and my task is to separate the blue points from the red points. What can I do? I can just find a limit. At the left of the limit, it will be like the left-hand side of the limit will be the blue points. The right-hand side of the limit would be the red points. So this one, it works, but maybe we see it's not ideal because it's a bit close to the blue. This one is much better. It's quite centered. So even if there is a bit of mistake in the blue one, in this blue point, and the blue point would be a bit more on the right, well, still it wouldn't change the decision. So yeah, here we have found like a limitation between the blue and the red. Okay, and that's what we will call a classifier, because it classifies which points are blue and which points are red. A classifier, also called a hypothesis. And so a hypothesis here, mathematically speaking, it will be a function h of x. X will be the coordinate of the point, okay, on your line. And h of x will be blue if x is lower than m, and h of x is red if x is larger than m. Okay, it tells me that if I take any point, I give it to my function h, my hypothesis h, and my hypothesis will tell me if this point should be blue or red. Okay? So very simple. Very simple. And actually, machine learning is nothing more than this. Okay, what if now the blue points and the red points are not separable? because it could be the case that here, there are some mistakes and there are some red points in the middle of the blue points. What then? Now, there is no line that perfectly separates them. Sure, but still, there are some lines that are better. This one, for instance, it will make 2 mistakes in the prediction. This one will make 3 mistakes in the prediction. So maybe the previous one, so the one making 2 mistakes, is better than the one making 3 mistakes. Okay? This one makes 2 mistakes again. This one makes 3 mistakes. So you can see that some make more mistakes than the others. So obviously, we would like to find one which doesn't make that many mistakes. Okay? And so that's the solution that is actually used, splitting the data set, but trying to make as few mistakes as possible. The number of mistakes here is what we call the loss of the hypothesis. It's called a loss because it's some kind of information that is lost in the process. I lose information by using the hypothesis instead of using the real data, because the hypothesis does not describe the real data perfectly. So there is a loss of information somehow. Okay, and what I want is to minimize my loss. Makes sense. Good. The loss in practice, in real system, is not necessarily only the number of mistakes. There can be more I would say, subtle ideas. But here, we don't have time to explore this, obviously, but still the idea is the same. You are losing some information by using a hypothesis rather than just using the raw data. Okay, that was a line. Okay, it's simple. But now, what if, for instance, my points are in a 2D space? If they are in a 2D space like that, so I would like to find also some hypothesis, some function that will map my points to whether it's a blue point or a red point. Here, the solution is simple. We can project. So project, I don't know if you have seen that in math, but project is just literally, for instance, here, take the points and take their and just move them back to the x-axis. Okay. So in doing so, all the points end up on one line. Okay. And on this one line, you can run exactly the same algorithm as previously and find the separation that minimizes the loss. Okay, so you transform a 2D problem into a 1D problem, and in the 1D problem, you can solve it easily. And I promise, I'm not lying to you, that's how AI works. Basically, nothing is more than this in AI. Then it's just very sophisticated ways of doing it, like what is done with neural networks. So you have very complicated data. You project somehow into some intermediate quantity, that you project again into another intermediate quantity, that you project again. But in the end, what you want is to end up on this line and finding a separation on this line between blue dots and red dots. So in the end, everything sums up to projecting on this one line and finding like a separation. On the left-hand side, you have the blue. On the right-hand side, you have the red. It's nothing more. Machine learning is just that. And you can see that it's absolutely not the way we humans are thinking. So machine learning intelligence, AI intelligence, is not the same as human intelligence at all. It's as different from human intelligence as pigeon intelligence is from our intelligence. So the question of should we trust AI more than pigeons is valid. So how we do machine learning in practice? We define the hypothesis. So this is here, for instance, the separation from the blue dot and the red dot. We define the loss. So what is the information that we don't want to lose too much in the process? And then we just find some parameters. So here, for instance, the separation, and that minimizes my loss. And that's what we call learning, because we find the parameters that we learn the parameters from the observations. Okay, so here, this is used, for instance, for images. So for images, we use this thing that we call convolutional neural network. And you see on this little drawing here is all the projection I said. So it's very complicated. I don't expect you to understand, and I don't want to explain it to you. But every single part of this drawing is just a projection that you are doing. Okay, and you're using a loss function which is called cross entropy loss. What it is, It's not your business today. Now you may object that large language models are probably more sophisticated. They must rely on more complex principles. And my answer is still no. No, why? Actually, large language models are just probabilistic systems that try to predict the following words. So they will compute probabilities for each potential candidate. So for instance, if I say Hamburg is, the LLM will compute the probability of each word following the is. So for instance, it will say that it's the with probability 32%. Okay, and after Hamburg is the, it will be must with probability 14% or only with probability 11%, etc., etc. Okay, so that's exactly the same principle. In particular, LLMs are not designed to rely on any form of knowledge. They are not designed to think and reason and to produce sentences that are correct. It happened that it works somehow, but we have absolutely no guarantee whatsoever that it works. And I love summing up this way by comparing ChatGPT to a parrot. They have lots in common. They run random sentences from random people. They both talk like a person, but don't really understand what the person is, what they are saying. They occasionally speak absolute nonsense, but only the parrot is a cute little bird. ChatGPT is not. Okay. Now I'm moving to the human part of this problem by stating that the real problem with AI is us, the users, the AI user. Why do I say that? First, because we are the ones giving the data to the AI. So we are the one telling the AI what is correct and what is not correct. And you can observe that the AI will have exactly the same biases as we do. For instance, we live in a sexist world. I mean, that's not to be proven. Then we can teach some things to an AI. And today we open AI systems, and this is something that is documented. We know that AI system that will say that a man is to a woman as a king is to a queen. Yes, makes sense. As an actor is to an actress. Yes, it makes sense. As a doctor is to a nurse. Oops. As a computer programmer is to a homemaker. Oops. This is not because AI is sexist in itself. It's because AI is just repeating what it's being told. Think of the parrot. If you say swear words to your parrot, the parrot will swear as well. It's the same thing with AI. AI does exactly what it has been told to do. The reason number two for AI, for us to be the problem with AI, is that AI will obey us, whatever we ask them. What do I mean by that? You might have already played with generative AI, so generating images. And so you can ask, I don't know, like picture of a dog running in the street. Okay, and you will have nice picture of a dog running in the street. Now, this is what happens if you ask a generative AI, so here Midjourney, to produce images of a few curbs, etc. This thing that I won't read, I just type random letters on the keyboard. The AI says, yeah, sure. I'm designed to produce images from text. So this is images corresponding to your text. Okay, so an AI will always obey. Okay, sounds funny, right? Yes, here it's a funny example. But in practice, it can create problems. Here's the problem. You know the game of Tetris, okay? Imagine you are trying to teach an AI to play Tetris. If you teach an AI to play Tetris, then what happens is that you will say to the AI, you should try to reach. I mean, to get as many points for as long as possible. So you should try to survive for as long as possible. Makes sense, right? If you do that, the AI will find a super nice strategy, which is pausing the game. By pausing the game, you are sure that you are playing for as long as possible. That is because the AI didn't understand what you meant. It understands what you say. Just play for as long as possible. But for the AI, playing is being in the game. And the AI doesn't understand that pausing the game is not playing. So if you don't specify this, the AI will obey blindly to what you are saying. And this is something which is called the alignment problem. Humans and AIs are not aligned. There is a big difference between what we humans want and what the AI will decide. Because the AIs and the humans don't speak the same language, so the AIs will need a full specification of problems. So here in the Tetris game, it needs to know exactly what we mean by playing, otherwise it will make mistakes. Also, because AIs don't have access to the implicit knowledge that we have, but also to the moral values that we have. Okay, so for instance, it's not able to sort out what is good and what is not good in what it will say. And the reason number 3 is that we treat AIs as humans. You will say, no, nonsense. Of course not. Why would we do that? My answer is we do that with many things. For instance, with teddy bears, with plush toys. We project some human traits onto them, right? So why would it be different with AI? And actually, think of it. Who among you says hi, please, thank you to ChatGPT? I'm quite sure that most of you do. But ChatGPT is not a human, so ChatGPT doesn't care if you say hi. Okay, so this is something which has been long known, and even in the 40s there were some studies showing that we can project some emotions and thoughts onto abstract entities and non-human entities. And here with AI, it's particularly the case because AI uses our language, so we can really identify into it. And this has 2 consequences actually. First consequence is that we judge AI to be more intelligent and capable than they are, because we just think they are humans, and they are not. So that's a problem. And the second problem, the second consequence, is that we forget that AIs don't think like we do and don't try to understand us. And that's a big issue. Which leads me to my work, human-centric AI. And that's what I work on my everyday life. So my vision is that actually we are in the real world, and the AI must not be thought in isolation. The AI tool must be thought as something that will collaborate with a human that is trying to solve a specific problem. So what it means is that I want to switch from a world where the standard human-AI interaction is that we say to an AI, please do that, and the AI does that, to an AI, and that's the third line, where the human and the AI work as a team. Okay, I can switch that, sorry. Now I'm ending the technical content, and I will give you a few words about me. I see in the chat that I have 5 minutes left. Okay. So how did I get there? How did I get to working on this? So let me tell you a bit of my life, not the most interesting part of the talk. So when I was in high school, like you, I had mostly 3 interests. Math was one of them. I really loved science in school, but I also wanted to become a pianist. Yeah, epic fail. And I was also super interested in philosophy. In the end, I went to the scientific side. And in my first years in uni, I studied math, I studied physics, and I studied chemistry. I was super bad at chemistry, but I had been said that, yeah, probably you should go there. So I went there. I dropped chemistry for as soon as I could because I was so bad, so terribly bad. But still math and physics were on my mind, and I wanted to become a researcher. I knew that from this time that I wanted to be a researcher. And then one day I made a project in the uni using the Kinect, this little camera developed by Microsoft. And that was my first step into machine learning. And I got completely thrilled by it. Then I continued with my master's degree where I studied AI. Now I was there studying AI, but for that I was studying computer science and math, a very, very heavy math degree. And I will come back to that. I did my PhD in Paris. So that is me not doing my PhD. So my PhD was on something, like PhD, very much not understandable, but super interesting. And in that, I was actually trying to bridge the gap between machine learning intelligence and human intelligence. And that's the first time I started having human elements in my thoughts. Then I went to Helsinki in Finland to work as a researcher, postdoctoral researcher, and I worked on many thrilling projects, more concrete, like for instance, something a bit like Duolingo for Japanese. So very, very interesting projects, and first contact with human-centric AI was amazing. And now I'm in Hamburg, in the TU, where I'm teaching and leading some research, and that's very great. And I will conclude this talk by saying that if I'm here, it's because I have been following lectures or I have been mentored by amazing people, amazing professors. And without them, I would not be here. So thank you for all of them. There is no chance that they're here today, but if they would, thank you for for everything they did to me. And like you, the students, I wish you to find your own mentors and this professor that will just lead you to the best of you. Also collaborators, and that's something amazing with research, that we collaborate and we work with so many interesting and different people, and I wouldn't be here without all of them. So thank you to them. And I will also mention that, I started by saying philosophy, music, art was my passion when I was in high school. Well, nowadays, I'm working with Jonas on the left-hand side on moral philosophy and AI. So back to philosophy. And I'm working with this guy, David Pletter, who is an artist, an Australian artist. And so I'm working on AI and art. So you see, my initial passions, now I can live them through my job. And that's crazy. As a conclusion, some advice I'm giving to you. Learning is not a duty, it must be a pleasure. I think you have seen during my presentation that I love so much what I'm doing, and have never seen learning anything as some source of something I must do. I just did what I wanted and I learned things I loved, and I'm so glad to be here now because of that. Second advice, math are the core of AI. So if you want to do AI, study math, don't neglect it, really. Really, I know math is not the funniest topic, but really you must master math if you want to do AI. My third advice is don't be afraid of difficulty. As I said, math is not necessarily the friendliest topic. Don't be afraid of studying. And you will notice at first you don't understand, and you work, and in the end you understand things. So never be afraid of difficulty, do it. And my fourth advice, don't let anyone tell you what you can or cannot do. And here, a special word to all the women who are listening to us. Computer science and math is also for you. Really, don't let people tell you that computer science is just for men. That's wrong. Study it. Do it as well. If you're interested, give it a try. You have your place here as well. So I'm stopping here. Thank you very much for your attention. And now I guess it's time for the question, I hope.